and not, you know. I just randomly found a sequence that works. Okay, where are we starting?
Problem 13.
Okay. So how do I find the inverse?
Uh,
Three basic steps. They're pretty simple.
so switch the x for the y.
Well, there's no y. So the first step really is to substitute y for f of x. Okay? In other words, sometimes they'll give it to you in terms of y, but all of these are in terms of f of x. So if we're going to use the two rules that you switch the variables and solve for y, then we got to get a y in. We don't necessarily have to do that. We could switch the variables and solve for f of x, and what you're really solving for is f inverse of x. But I kind of think most students are more comfortable with doing it this way. So always switch the f of x to a y. Now switch the variables. What's the next line?
So uh, y or x equals 6y.
Now solve for y.
So x over 6 or 1/6 x.
Okay. Now, that's not the same y as this. This y is 6x, this y is x over 6. That's because this y is actually the inverse of f. I can really write that if I go back and write it in terms of f of x terminology, then I get f inverse of x equals x over 6. This would be my answer. Now, they said graph both. So, graph the function itself, 6x. It's the y-intercept. If I want all my functions to be in this format so that I can graph them easily, then I have to know how to put that into that format. What is b?
6.
0. M is 6. It's the coefficient of the x that is the 6. So what else is m called? What word?
The leading coefficient.
Slope.
Oh.
Slope's one of the most important words in all of math. And it doesn't matter whether you're in Algebra 1, Geometry, Algebra 2, or hard calculus. Slope is unbelievably important. Okay? So, I've got a y-intercept of 0. I got a slope of 6. Where do I start to graph this?
So um, the y-intercept is 0.
Okay, so I start there. Now what?
The slope is up 1 over 6, I believe.
Slope is rise over run.
Right.
So it's got to be up 6 over 1. The rise is 6. The run is 1. Okay? So it's up 6, but even over is not sufficient. Over which way? Do I go right or do I go left?
Right.
Because I have a positive slope. I want to make sure that I get a positive slope when I graph it. So that's the slope of y equals 6x. Well, our inverse is y equals 1/6 x. So where does that go through? What's its or y-intercept?
Um,
Down here.
so
Remember, you're putting everything in terms of that because you know how to graph that.
so
What's b?
0,
Okay. What's the slope?
6/1. So
No, it's not 6/1. That was the slope of the first function. This function is y equals 1/6 x. Different function, totally. So what's the slope?
um, up 1/6.
Okay. Up 1 is correct. Over which way? If I go left, it's not going to be correct. So it's got to be up 1 and to the right 6.
Okay.
Now we have two positive slopes, which is correct in both cases. 6 is a positive number and 1/6 is a positive number. Now I'm going to point out something else here. And this is true with all inverses. Every inverse, and it doesn't matter whether you're talking calculus or anything else, the inverse is a reflection about that blue line. That blue line's equation is y equal x. All inverses are reflections about the line y equal x. It's an invisible line, but this lower right line, red line, excuse me, is the reflection of the first red line about that blue line. Do you see that? And that
Yeah.
cases with all inverses by definition. And so what that kind of means is the following, is that to graph the second one, I didn't really have to solve it for that. All I had to do is graph the first one, and now I'm going to try to draw the reflection of that first line. Well, the reflection of that first line is like that. That's a perfect reflection of the first red line. So this is the inverse. And we know what it is. F inverse of x equals 1/6 x. That's that lower line. All right. We doing all or odds? Every third?
Through 20.
13 and 20?
13 through 20.
13, 3, and 20. What does that mean?
13 through 20.
Excuse me.
So
I kept
all the
hearing
way
the word
through 20.
3 and you were saying through. Okay. So 14 next. So find the inverse.
So
Tell me what the steps I should write.
it's
I'm going to do it over here on the left. So what's the first thing I got to write?
y equals -3x.
Okay, what's the next thing I have to do?
Divide by -3.
Oh, switch the variables. Switch the variable. That's always the first step of finding an inverse, is to switch the variable. You can't do it though as long as it's in terms of f of x. you got to put y in place first before you can switch the variables. So switch the variable.
So,
The equation on the left. Switch the variables. Real simple.
x equals negative 3y.
That's switching the variables. Now the last step is to solve for y. Always the same 3 steps. What's y equal?
Negative 1/3 x.
Only that's not the same as the original y. This is actually the inverse. So we're going to call it f inverse of x. Okay, now let's graph them. How do you graph y equal 3x, the first one? The original function. Excuse me, y equal minus 3x. Where's the y-intercept?
So the x or y-intercept is at 0.
Okay, what's the slope?
Down 3, right 1.
Correct. So there's the original thing graphed. Now, I could draw that blue line and try to reflect this red, but that's actually not going to be the easiest way. The easiest way to graph it is to graph what's minus 1/3 x look like. Where's the y-intercept?
It's also at 0.
What's the slope?
Down 1, right 3.
Whoops, I meant to go through that point. But so this is y equals minus 1/3 x. This is, that is y equal minus 3x. And one is the inverse of the other.
Oh, yeah.
All right, hold on a second. Let me get this. Okay, 15. Same 3 steps every single one of these problems. Read the first 3 lines off to me.
So y equals negative 2x plus 5.
Second step.
X equals negative 2y plus 5.
And third step.
Negative 1/2 x.
Hold on. Third step is to solve for y. So what's the first step in solving for y?
Subtract 5.
Okay. And then what are you going to do after that?
Divide by negative 2.
There you go. That's your inverse. And now I call it the inverse. I don't leave it as y because that's misleading because it makes it look like that y is the same as that y, and they're not the same, obviously. Okay. Now,
Right.
let's graph the first one. Where do I start?
So
There's the y-intercept.
The y-intercept is at 5.
It's a slope.
Down to right 1.
Okay, I'll make it look like that. So that's the first line. And we know the next one is the reflection of that, but that's kind of hard to see. So it's easier to figure out how we graph that. Now let's go back and look at this one on the bottom. If I'm trying to graph this, it's not really in y equal mx plus b format yet, is it? I got to get it into y equal mx plus b format before I can graph it. And what I'm going to do is separate it into that part and that part. So do that.
So negative 1/2 x minus 5/2.
It's negative 5 divided by a negative 2.
Oh.
Plus 5/2. Now, tell me how to graph that. That's our inverse function. Where do I start?
The y-intercept is at 2 1/2.
You can say 5/2. It's right there. I actually prefer improper fractions always. I never prefer proper fractions, ever. It's easier to just work with fractions. And what's the slope?
Down 1, right 2.
So that's a flatter line. But that's it. Now, it's kind of hard to see where that's a reflection off of this line, but it is. In other words, a point that's on this line, when I reflect it, it becomes there. And a point way up here reflects to become there. So figuring out how to reflect over the blue line is not the easiest thing in the world to do. In fact, in these cases, it's actually easier to just put it into y equal mx plus b format and graph it. It's a linear equation. Once you know it's linear, if you can get it into y equal mx plus b format, you can graph them.
Okay.
Okay, 16. Give me all 3 steps.
So y equals 6x minus 3.
Next line.
X equals 6y minus 3.
Keep going.
And then x minus 3 over 6.
No. How do I get rid of that negative 3?
Oh, sorry, plus 3. So x plus 3 over 6.
And again, notice that this comes out in a similar kind of form. That's not in y equal mx plus b. So let's change it while we're looking at it. How should I write this? Instead of x plus 3 over 6, if I want to put it in mx plus b format, what is it?
Y equals 1/6 x plus 1/2.
Correct. Now, graph that one.
So the y-intercept is at -3. And then the slope is up 6, right 1.
And graph the other one.
So the y-intercept is at, or x-intercept is at.
No, you were correct in the first place. It's still called the y-intercept. That is the y-intercept.
Okay.
Forget the fact that you switched variables. Just assume that this is a whole new function. Just happens to be the inverse of the first function. But we're going to graph it just like we would graph any y equal mx plus b.
Okay. So the y-intercept is at 1/2.
And what do we do?
Up 1, right 6.
And you can kind of see that that definitely is a reflection, right? In other words, if I draw that line y equal x, the green and the red are definitely reflections of one another about that line. But still, it was easier to graph just as two different equations. Just was. All right. 17. Read them out. These go pretty fast once you get the pattern. That's all it is, a pattern. You're doing the same 3 things every single problem.
Yeah. So, y equals -1/2 x plus 4.
Next line.
X equals -1/2 y plus 4.
And next line. You can do it in 2 steps. You don't have to do it all in 1 step.
So x minus 4 equals -1/2 x, or y. And then,
Now, in some cases, it's actually easier to see that as the same as this because it's easier to do the algebra. In other words, when I see this, I know I got to multiply both sides by -2. When I see this, I got to divide both sides by -1/2, which sounds a whole lot tougher. It's the same thing. Dividing by 1/2 is the same as multiplying it by 2. It's just that when I write it like this, you can clearly see that the 2 is a denominator, which means I've got to multiply -2.
So -2x plus 8 equals y.
Yep. -2x plus 8. And I'm going to just say straight away that that's equal to f inverse. Okay. Graph the original function. I'll graph that in red, and the second one in green.
So the y-intercept is at 8.
Doing the first one first. Always do them in the same order. Don't do them backwards. It's 2.
Okay, so it's 4 then. And then down to right 1.
It's rise over 1.
Ah, crap. Down 1, right 2.
Okay. And always check to make sure your slope is the orientation you want it. I want a negative slope, I got it. It's easy to get the wrong way and not recognize it. Okay, now go down and graph the bottom one.
So the y-intercept is at 8. And then it's down to right 1.
So down to right 1, that's a steeper slope. And there you have it. Every problem is exactly the same. You're doing everything exactly the same. So, are there any more after 20?
Yes.
Why don't we
The
stop
next,
there, and then if we still have time, we'll come back and we'll finish 18, 19, and 20. But I think you can see there's nothing different about them, right?
yeah,
They're all linear. You're going to be able to graph them using y equal mx plus b. It's all the exact same strategy for figuring out the inverses.
right.
So what's the next one after 20?
22.
That's up top, isn't it?
Hey, bud. You done with you on a meeting right now?
Yep.
I just dropped off the food. Is this mine?
Yes.
Oh, sweet. I'm gonna go to the restaurant.
Yeah.
You might have to go.
Is the first function. When they say determine if, f and g are inverses, they're saying compare that. Here, let me. All right, here's f of x, here's g of x. Okay. We have to figure out if they're inverses of one another. Now, here's what's true about inverses. Let's go back to the problems we just did. Okay.
Okay.
If I said f of 2 was equal to 3, then by definition, f inverse of 3 is equal to 2.
Right.
If I said f of 4 equals 0, then tell me what the inverse should read.
F of 0 equals 4.
Okay. So that's the rule we're going to use to answer these.
Okay.
So let's take f of x. We can see that f of minus 2 is minus 2. Excuse me. Based on this, I can see that f of the x value, which is minus 2, is equal to the f of x, minus 2. Well, that's not going to be real helpful, because if I look at the g function, yeah, g of minus 2 is also minus 2. So let's pick some other numbers other than those first two. Those don't really clarify the situation much. So let's take the second column. What is f of minus 1 equal to?
1.
Now now they want to know if f and g are inverses. Well, now let's go down and look at what g of 1 is. If it's minus 1, then so far so good. Is it? Notice what I'm doing. I'm switching the domain and the range. Yeah, if I look at that column right there, when x is 1, g of x is minus.
Is negative.
Oh, it's minus 1.
Right.
It's in the same column. Don't look
Okay.
down here yet. That's question B. We're doing question A, which is merely comparing f of x to g of x. Okay? So, what we can see is that these things need to be swapped. If g of x is the inverse of f of x, then these numbers always are swapped. Notice that they're swapped there. They're swapped there. They're swapped there. They're swapped there, and they're swapped there. You know what I mean by that?
Yeah.
Okay, that makes g of x the inverse of f of x. Yes, for A. I should write it up here. Yes. Now let's look at 2. Are they swapped?
No.
No. Fails the very first test. No. Now let's look at C. Is C swapped?
No.
Simple as that. If they're not swapped, they're not inverses. When you create an inverse of a function, you're swapping the domain and the ranges. Always. So it's real easy to figure out B and C real quickly. Okay, what else do you have after 22?
31 through 38.
Oops. Where are those? Oh, I see. All right, these are easy because we don't have to do any math. We just have to figure out the graph. What is necessary, first of all, for the inverse to be a function? First of all, what's it take for a function to be a function? What's the primary rule? What test does it have to pass?
I believe it's the horizontal line test?
Vertical.
Vertical line test.
In other words, each of these 4 functions passes the vertical line test. Right?
Right.
And by that, I mean, no matter where I draw a vertical line, I will only hit the y value once. Only one y value. Same thing there. Doesn't matter where I draw that vertical line, I'm only crossing one y value. Same thing there, same thing there. So all 4 of those are functions. Now, for the inverse to be a function, has to pass another test besides the vertical line test. What test?
The horizontal.
Correct. Notice the first one fails the horizontal line test immediately. It goes through the values. So, no, its inverse is not a function. 32 fails it immediately. That inverse is not a function. 33 fails it numerous places. Fails it there, fails it there. That is not a function. Now, 34.
It's a yes.
It's a yes. Because no matter where I pass a vertical line, even at that or a horizontal line, it only goes through the graph at one point. Therefore, that is a function. And what is that function? Well, the function we're looking at is y equals x cubed minus 2. That's that function. Okay? So tell me what the inverse function would be.
It would be
Only 2 steps this time because we didn't start with an f of x, we started with a y. First step,
x equals y to the third minus 2.
next line,
X plus 2 equals y to the third.
next line,
The cube root of x plus 2 equals y.
correct. And that is a function. Looks something like, it's always hard for me to draw those, something like that. In other words, you can see that the red squiggly I think I just drew in there is the reflection, well, not quite, more like this. It's hard for me to draw inverses. I just am not good at reflecting about a line. If I just did it point by point, I could do it because this line is the same distance from that diagonal as this point is. So to draw an inverse, you can just do it that way. Just find point by point and connect the dots and you'll have the curve. But it turns out that that is a function. For every value of x, there is only one value of y.
Okay.
35 next. 31 through 38.
Yes.
So determine whether the inverse of f is a function and then find it. Well, it's an awful lot like 34, right? So is the inverse going to be a function? It's basically 34, only with a different, look at 34. Remember what this was? Here. Just a second. Okay. 34 was y equals x cubed minus 2. Well, this is x cubed minus 1. So it's real similar. So find the inverse in 35.
X equals y to, wait.
That's correct.
Yeah, x equals y to the third minus 2.
Minus 1. We're looking at that one right there.
Oh,
We're not
okay.
looking at the previous problem. The previous one was x cubed minus 2. This is x cubed minus 1. So when I swap the variables, I get this. Now solve it for y.
So the cube root of x plus 1 equals y.
Yeah. Now determine whether the inverse is a function and then find the inverse. Well, we knew it was a function because it looks just like that. So if 34 is a function, then 35 is a function. Excuse me, if the inverse of 34 is a function, which we decided it was because it passes the horizontal line test, then the inverse of 35 is a function. It's also going to pass the horizontal line test. Okay? So that's all we have to really do is graph these and see if they pass the horizontal line test. That's one way to determine whether the inverse is a function. Let's graph them and see. That's the easiest way, I think. So let's look at 36. How would you graph that? It's that, only the negative of that. So if I was trying to graph, say, y equal negative x cubed, well, it's going to be that, only the reflection of that. So it's going to start up here. It's going to go down through that, and then like that. You see where that is that? In other words, the leading negative sign means it's the reflection of y equal x cubed. The reflection over the x-axis, not over that diagonal line. Well, the only difference here is I'm adding 3 to it. What's the consequence of that plus 3?
It goes up 3.
So there's our graph of minus x cubed plus 3. Does that pass the horizontal line test?
Yes.
Okay, now find its inverse.
So
Three steps. Start with an f of x. There's always 3 steps. What's the first step?
Y equals negative x to the third plus 3.
Second step.
X equals negative y to the third plus 3.
Next.
And then
do it in 2 steps.
So x minus 3 equals negative y to the third.
Now get rid of that negative sign. Believe it or not, if I divide both sides by negative 1, this turns this into 3 minus x. You just swap them.
Oh.
You with me?
Okay. Yeah.
That's always true. A minus b is always the negative of b minus a. Okay? In other words, a minus b is always equal to minus b minus a. So when you divide that by negative 1, you're switching it to b minus a, which is all I did. And now what's y equal to?
This cube root of 3 minus x.
Correct. And we know that that is a function. That's its inverse. But we know it's a function because the original graph passed the horizontal line test. As long as the original graph, in other words, we don't have to graph this and give it the vertical line test. That'd be one way to do it, is to graph this, which is a little harder to graph, quite a bit harder to graph, actually. But it's easier to just give the original function the horizontal line test in order to know whether its inverse is going to be a function or not. All right, number 37. First of all, I'm going to graph it. This is the square root function, which normally graphs like that. But in this case, it's horizontally shifted which way by how much?
Left by 4.
Okay. So it's not that, it is this. Instead of going through the origin, does that. Okay. So that's the graph of f of x. Is that a function?
Yes.
Does it pass the horizontal line test?
Yes.
Is its inverse a function? We know the answer is yes because the function passed the horizontal line test. In other words, I don't know what the inverse looks like yet, but I know that the function passes the horizontal line test. Therefore, whatever its inverse is, it's going to be a function. It's going to pass the vertical line test. This is what a thing has to do to be a function, is it has to pass the vertical line test. Okay, so let's figure out what it is. We've answered everything except what is the inverse. So, number 37. Line for line, read it.
So y equals the square root of x plus 4.
Okay.
And then x equals the square root of y plus 4.
Okay. Remember, you're solving for y. What is the next step?
So x squared equals y plus 4. And then, so it's x squared minus 4 equals y.
Yeah. And notice what that is. That's a parabola. Opening upwards, shifted down by 4 units. There's the inverse. Okay. And the inverse passes the vertical line test. That makes the inverse a function, which we knew already because the original function passed the horizontal line test. So we didn't have to, this actually, yeah, no, this is correct. Okay, yeah. All right, let's see if we can finish up 38 before we're done here. Graph it first.
So it's the vertex is at 6.
It's not called a vertex. You could call it the beginning point, I guess. You're right. It's at 6, 0. But the way you want to talk about this is it's the square root function shifted 6 horizontally. So look,
Okay.
okay? Now, from that alone, is its inverse a function?
Yes.
Okay? So we've answered that. Is the inverse a function? Yes. Now let's find the inverse. Now the easy part. Okay? Give me the lines.
So y equals the square root of x minus 6.
Okay.
And then x equals the square root of y minus 6.
Okay.
And then x squared equals y minus 6. And then y, so x squared plus 6 equals y.
And there you go. There's the function. Again, we know how to graph that. That's a parabola. Moved up by 6. In other words, goes through the origin. Oops, excuse me. Goes up by 6. So it's like that. And notice that that is a function. In other words, once we have graphed the inverse, it only has to pass the vertical line test to be a function. The original function has to pass the vertical and the horizontal if its inverse is to be a function. Only has to pass the vertical for it to be a function, but it has to pass the horizontal also for its inverse to be a function. It's that simple. Okay?
All right.
Now, got any more after 38?
Yeah.
What do you got?
49.
Okay. I really don't think we need to go back and finish those ones we didn't do. You knew how to do them. They were all exactly the same.
Yeah.
Okay. 49. It's good we're going to do one of these, at least. Now, there's two ways to do this problem. First of all, we could just take that function, 2x minus 9, figure out what its inverse is. If it matches that, then they're inverses of one another. But there's another way to do these that's actually maybe a little more efficient, or not. Let's do it for at least one of them.
Okay.
In other words, I know you know how to find the inverse of f of x, and you'll get x over 2 plus 9. So yes, g of x is the inverse of f of x. I just recognized it, okay? Ah, hold it. Maybe it isn't. Maybe it isn't. No, I don't think it is. Let's see. Y equals 2x minus 9, which means x equals 2y minus 9, which means x plus 9 equals 2y, which means y equals x plus 9 halves. That's the inverse. That's not what we're looking at, is it? Yes, it is. That's the same thing as that. In other words, no, it is not the same thing as that. Those are not the same. This is 1/2 x plus 9. This is x plus 9 over 2. So they're definitely not inverses of one another. But we kind of did it. That's not really the way you're supposed to do it. Let me just explain this, and then we'll do it on this one problem. Here's what has to be true. F of g of x has to be equal to what? For these things to be inverses of one another. X. That's how you tell whether two functions are inverses of one another. Now, this is called a composite function. Have you had these?
Yes.
Okay. So, looking at 49, what does f of g of x mean? Means f of what? What is g of x?
F or so yeah, 2 or x over 2 plus 9.
So that's your first step when you're trying to figure out what f of g of x is fill in the g of x part, okay? Now, if I go up here and I look at that f function right there, and I said to you, what is f of 3, what would you do?
Plug 3 in for x.
Okay, that's what you always do. In other words, down here we have quite a bit more complicated expression. It's not a number, it's x over 2 plus 9. But we're going to do the same exact thing. Wherever we see x, we're going to plug in x over 2 plus 9. Okay? So,
Okay.
f of x
Equals.
or I should write it like this. F of g of x equals 2 times x over 2 plus 9 minus 9. Correct?
Yeah.
In other words, is all I've done is taken the f of x function, and wherever I find x, I plug in g of x over 2 plus 9. Now, if you do the math here, you get x plus 18 minus 9, which is x plus 9. That's not x. In other words, f of g of x has to be equal to x. Otherwise, g of x is not the inverse. That's how you prove it, is you take the composite function. And it's not just f of g of x has to be equal to x. The reverse also has to be true. G of f of x has to also be equal to x if you did it the other way. In other words, if you start with the g of x function and you find out what g of f of x is. But this is the number one rule for inverses, is the composite has to equal x. And when we tested 49, we didn't get x. We got x plus 9. Has to equal x exactly.
Okay.
Okay? All right. That's a good place to stop. Dimitri, I will talk to you on Thursday.
Okay. Yep. You too.